Hello Internet, welcome to my living room. I don't know about you, but I find 3D printing fascinating. I've been watching it for a while, following Thomas Sanladerer on YouTube. He's a German industrial engineer and designer and very talented and knowledgeable, shares a lot of interesting videos, historically mostly about fusion deposition, so things like MakerBots and LulzBots and the kind of things where you feed in a filament of plastic, it melts and prints a 3D part, which those machines have always been of interest, so I've been following them for a while. We have a couple that work, and I printed a few objects both for fun and curiosity with my own filament, and also professionally to help visualize some of the scientific things that I work with at work. But personally, my interests for home use don't necessarily fit in with the filament-based printing. So recently on Maker's Muse, I saw a video on masked-SLA printing. Historically, resin-based or SLA printers have been extremely expensive, but a kind of a new development is using an ultraviolet light source in the base shining through an LCD screen from something like a smartphone, actually exactly a smartphone or a tablet, and basically by using images on the screen, it masks off the UV light, which cures the resin in the bath. And so all of those parts, thanks to the explosion of smartphones recently, has made these 3D printers pretty accessible for a home user. So I finally jumped in as a belated birthday present to myself, and today everything showed up well, I was gonna say at my door, not quite. I missed the UPS delivery and didn't want to wait until 9 o'clock when it got back to the UPS distribution center, so I chased down the UPS truck using their handy tracking app on the internet and got my printer. If you've read the title, you probably already know this is an Epax X1 masked-SLA 3D printer. I got this refurbished directly from the Epax website. I got lucky that they had an X1. It saved me about 150 bucks, so I was pretty happy about that. And then I have, so this is again my living room, so I have some accessories. So basically I'm gonna unbox a whole 3D printing setup, I hope. Well, I hope that it's the whole setup, otherwise I'm gonna get to some step and have to stop recording. That's gonna happen anyway. Okay, so I'm babbling. Without further ado, let's unbox some stuff. So starting with the smallest package first, X-Acto knife, utility knife. So this is a box from Epax. So when I got the printer, it had the option to buy resin along with it, but I was looking and I said to myself, well, these resin prices are kind of high, so I'm gonna skip and just order them someplace else later, and place the order for the printer. But then I actually went looking at printer prices, and Epax's prices are surprisingly reasonable, it turns out. So in this box I have a standard clear ESUN resin. So I like seeing the inside of things that I print. I don't know if that's a quirk of my own brain or if that's a common thing, but so this is a clear resin. So shake well before use, avoid direct sunlight, and operate it between 20 to 28 degrees Celsius. That's a fairly narrow window. Anyway, should be okay. Although I guess it should be okay. So I think that 28 degrees Celsius is about 65 degrees Fahrenheit. So it's about 70 Fahrenheit in here, so yeah, that's about right. So this second bottle, how many of these did I get? I can count, but so this is another ESUN E-Resin PLA. This is a bio resin, so it's derived from plant matter. It's supposed to have a less odious smell to it, and also less significant health effects for human users. And I have a dog, so she probably would prefer not having so much of a smell. And I would like to prolong her life as much as possible. It doesn't sit flat, so that, whatever, they appear to be aluminum canisters, so unimportant detail, but is what it is. And then, so I guess I believe that I got 2 of these. So I got a liter of standard resin, so it came in 2 500 milliliter canisters instead of 1 larger one, so that's fine. So I'm gonna, just for curiosity, shake well before use. So that's a little surprise. Oh, okay. So shaking it up probably homogenizes it to some extent, but it's also incorporating air bubbles in the resin. So I'm kind of surprised that this is how the system works. I'm not sure if it's best practice to shake well a bit before use and then let it sit for a while, which is probably what I'll do to let some of the bubbles sort themselves out. This has also been in a box on a UPS truck, so the canister is a bit cold, so I should probably let it reach room temperature before actually using it. Otherwise the viscosity is going to be different and it might not print quite as well, and since it's cold it's going to attract moisture from the air. Fine. I'm going to hold off on opening this so that it warms up a little bit first. Sorry, we'll come back to that later. Set those aside, set this aside. Okay, the next box is this giant one. This is not the printer. Since we're doing this in my apartment's living room, which is, says it right in the name, a living space, and 3D printers kick out some particulates and vapors and some other junk. This is actually an air purifier, which I've been thinking about getting for a while since I have a dog, and she has fur and dander and all kinds of stuff. And I live in Maryland, where we get lots and lots of tree pollen in the spring, so an air purifier is not only for this 3D printer, but it is the strongest rationalization I had, and the reason why I picked it up is because 3D printers kick out vapors, and the carbon activated charcoal or carbon filters in an air purifier will help pull those out of the air and make a safer living environment that I can share with a 3D printer and my dog. So this is a Bissell air purifier. Picked it up on the internet from a large retail company, which will go unnamed, because I have feelings about that, but the price was right and lower than anywhere else. So this is larger than it looked in the pictures online. I'm gonna throw this box. It didn't hit anything. By the way, I have the world's most precarious lighting setup for this video, so things could come crashing down at any moment, but we'll hope not. So this is sleek looking, and table. It's Bissell Air 400. It's supposed to be able to purify a 400 square foot living space, I think once an hour, which seems absurd. But it's two, or I guess it's a 3-level filtration. There's a pre-filter to pull out large dust particles, then a carbon filter to pull out volatile organic compounds, which the printer is going to kick out, and then a HEPA filter to pull out allergens, microbes, fur, dander, tiny particles down to something ridiculously small. So hopefully, well, okay, this is not going to keep me safe from the volatile organic compounds, but it will help reduce their concentration in the air in my apartment, so that's going to help. So I guess I'm going to, well, so it's got a lot of stickers on it. This one says to read the directions before using, but, well, seems like it might be better. Got a little door in here with a little, I want to open it and find out what it is. Just need a screwdriver. I'll be right back. Okay. Hello. And of course the screwdriver I grabbed doesn't work. I'll be right back. Oh, that's a... the label tells you what it is. It is a particulate sensor, and apparently you unscrew this to clean it. This is a Victorinox portable screwdriver that has a regular hex bit on one end, or a socket for a hex bit on one end, and a ratchet mechanism on the other. I carry it in my pocket at work, and it's actually quite handy. But, all right, I don't want to. Well, I was gonna say I don't want to strip the head. I also don't want to declare defeat, but I also just dropped the screwdriver. Okay, let's keep trying. I have a couple of different screwdrivers. One of these is bound to work. I don't want to strip it, especially because it's just out of the box. That one won't work. And this one will work. So that's the particulate sensor. It's got a little opening in it, and it looks like this is just a pre-filter for the particulate sensor. So that's all that is. There's a little, looks like a little mosquito screen. Cool. Okay, so let's put that back in. That was fun. Got some adhesive on it. That's back together again. Okay. And then we'll keep turning this thing. So that is the filter. Open this up. It has some warnings. Good thing I opened this up because this filter comes thoroughly wrapped in plastic, so I'm going to remove that plastic. There's a dull razor blade. I should place that. All right, tells me. So it tells you which way is the top and the front. That's handy. So this is the HEPA filter, so it goes in, so it's the last thing that the air sees before getting exhausted to the environment. Next, this is the activated carbon filter. It helpfully also tells you what's the front and what's the top. The do not wash is kind of interesting. Makes sense. I mean, the carbon, well, I guess I won't wash it. Wouldn't fit in my dishwasher anyway. But yeah, I guess when that's caked up with chemicals and stuff, it's probably best to throw it out. And then I was wondering if this is supposed to go in, but it's got Velcro on it that sticks to the front top. Yes, okay, so that's correct. So yeah, the Velcro indicates to me that it is in fact supposed to be on there. So don't worry, I'm going to go through and read the manual later. But for now, I kind of want to plug this thing in and see how noisy it is and give it a chance to purify some of this air while we're unboxing the other thing. So keep rotating, so there's anything on the far side. There's not. So this is the front of the unit. It has peel screen. Very satisfying. Okay. So. It does have a handy notice that before you operate this machine, you should remove the back and take the plastic off the filters. So you don't even have to read the manual. It's all in stickers for people like me. I guess I should show. So it's also got some buttons on top for power, modes between maximum, auto, and silent, fan speeds for low, mid, and high, a 1 hour, 4 hour, and 8 hour timer, and a filter reset button, and another piece of protective wrap. All right. So I'm going to plug this in and try not to knock over any lighting equipment. I call it lighting equipment. It's really just lamps. Okay, press the power button. It beeped at me. All right. Okay. I have put that on automatic mode. I can hear the fan running, but it's not intrusive. It's honestly not as loud as I kind of expected it to be. So it's probably a large diameter blower spinning at a reasonably low speed, so it doesn't have a high-pitched whine or so I have like a Vornado cooling fan that is very effective, but it's extremely loud. So I don't know. It seems like Bissell has done a good job of engineering this filter to be run kind of long-term in the background without invading your space. So. Okay, that's enough procrastinating. Let's get to the last box. This is the refurbished Epax X1 3D printer box. So I ordered it. So I'm in Maryland. It shipped the next day which was Friday, from Durham, North Carolina, and got here today, which is Tuesday. So the shipping was quite fast. So this is, this is plexiglass orange panel. So the model that I ordered, honor produced by Xintao. The model I ordered has a black window, and I thought, well, the orange ones look cool, but they're also not as effective as the orange one, or the orange window is not as effective as black windows at blocking out UV light from the outside, which can disturb your print, and it's also not as effective as preventing ultraviolet light from inside the chamber from escaping and like blasting your eyes. So I ordered this. It was $10, so it seemed like, why not? But honestly, I don't think I'm going to install it. I might keep it for something else. Well, I will keep it. Probably use it for something else. We'll see. This is a paper filter funnel, I think, for resin. So looks like they hand wrote on the packing slip that they recommend using the included spacers when installing this orange window. So that's a nice touch. Humans are involved in the process. Shocking and dirty. So it says, please read the manual PDF file and the included USB stick first, and try to print the test file lampshade.cbddlp in USB stick first, and join our Facebook group. I'm not sure I'm going to do any of that. I'm not going to join their Facebook group because I'm trying to stay off of Facebook. It's hard. My whole family's on there, but whatever. This is the 3D printer user manual. They have some big models. This is the very smallest model out on the end. So I guess there's room to grow. I wonder if I could use this one to print. Anyway. Okay, yep. Looks like a printer. So we have a power brick. I believe it's a 12 volt 6 amp, so 72 watt plus or minus power factor. Oh no, that's DC, yeah, 72 watt, but it probably draws more than that. This is the build plate. So this is a refurbished printer, and they warned on the website that there might be some scratches on it. I'm not sure if any of it, no, okay, it looks like it's a bare reflective plate on there. But looking at it, there are a few, I would call them blemishes. I mean, they are scratches, but not a problem at all. So they're superficial, it looks like. So there's some texture to the build plate. And so the scratches just kind of disrupted that texture, but not much, and I think not enough to actually create any much opportunity for the resin to stick inappropriately. So I'm okay with that. So they did include, so this is refurbished, so the one thing I wasn't sure about is if they had an extra film for the bath, but they do. It's labeled film, so that's handy. They have a little, wow, okay. So in this toolkit, I'm not sure if that's a bronze colored or a rusty Allen key, but the surface finish looks nice. So I think it's just colored or coated in something. So this is an Allen key for, I suppose we'll find out. And a yellow plastic chili scraper, I guess just in case you don't have a paint scraper, which is a safe thing. There's a sticker in here for that it checked quality control. Cool. A power plug with a zip tie on it. So I'm going to use these handy new flush cut side cutters to get rid of that. Not that I don't have 100 of these power cords kicking around from too much time spent building computers, but always use the new one, right? New is always better. So I can just plug that into a kilowatt, because I'm curious how much power this thing actually draws when it's running. They also included a paint scraper, which is a nice gesture. If I don't know if you can see, yeah, you can kind of see the build or the quality of that surface. Come on, focus. Well, I would not use this because it's been ground off. You can see scorch marks on the metal, so that's a really bad machining job. It's also bent. I don't know what happened to this thing, but it's had a sad life. And I picked up at a box store a paint scraper of my own and spent some time putting a sharp edge on it. You can, very reflective, you can see my whole house. So you can see there's an edge. It's pretty sharp. I could cut myself on this if I was not careful, which I'm not, so I'm going to stop touching it. Yeah, so I'm not going to use the included scraper, but if I didn't have anything, I guess this would be useful, which means that this is probably not a scraper for removing parts off the build plate. It's probably a scraper for moving resin around or checking the resin chamber for residues. So that's cool. Okay. That's a sticky large block of styrofoam. Oh right. Easily distracted. I dropped. So when I opened that little baggie with the Allen key and yellow plastic thingy, which I've already gotten plastic junk on. This place was clean yesterday, I swear. I dropped this SanDisk 8 gigabyte USB micro dongle thingy. So that's nice and compact. That's cool. Okay, so it's cool that it's 8 gigabytes and that it's compact. the Epax X1 uses the USB stick for transferring files between a computer with the slicing software and the printer itself. So the fact that this is a nano stick, I mean, it's got a couple of ridges on it, so you can probably pretty easily, or you can get a grip on it. But I prefer larger sticks that you can actually get an easy grip on for transferring things. So I probably won't use this, but it's nice that they included it. Again, if I didn't have a handy USB stick or wasn't sure what I needed, I could use this, no problem. So that's cool. I have USB sticks, so I brought my own. Well, I'm at home. So this is the printer. It is, let's see, so the entire box weighed 23 pounds. There's probably a half a pound or a pound of packing material in there. So yeah, this is a 20-pound printer, which, so I learned about, so again, my first introduction to the masked-SLA printers was through Maker's Muse review of the Elegoo Mars, which is kind of a competitive printer. It's, I think, $100 or $150 cheaper than this one, although new, it's not that much cheaper than the refurbished one. But that has I think it might be metal base, but I think it's a plastic base. A plastic cover is all plastic. Maybe less durable, although I wouldn't expect a lot of impact on, except for idiots knocking on them, I wouldn't expect a lot of impact on a 3D printer, so I mean, that's not really a problem. But the fact that this is a sturdy metal frame is nice, and it also means that it's a heavy, chunky piece of kit. So it feels satisfying in an old school manufacturing kind of way. Practically, I don't think that it makes a difference unless you play baseball in your living room, which, you know, some of us do. I don't know why they wrapped it in saran wrap. A little bit annoying. But, I mean, it would protect the surface from abrasion, but it's metal, so it doesn't really need that. Bubble wrap would, well, whatever. Not going to complain about their packing practices. I'm no expert in that field, so don't know. Okay, I hope that didn't come out super loud in the video, because that's a lot of plastic wrap. It was wrapped, I don't know, I can go back and count, but a lot of times. So this is the back of the printer. Immediately noticed a door with Allen keys. Welcome back to you. So this is the side, which has the power switch and USB port and a fan port, fan exhaust or intake. So that's cool. The Elegoo Mars had the USB port and the switch on the back, which was a common complaint. So it's nice that this is on the side, pretty close to the front of the machine, pretty easy to get to. Here's the business end. So it's got Epax 3D. This is the X1 model. A nice metal door. The black window, which looks, so it, honestly on their website it looked opaque to me, which is part of the reason I ordered the orange kit, because I do want to see in. But when you let a little light in, you can see it is transparent or translucent. It's also got streaks on it, so it's apparently been cleaned, just not well. So that's nice. So this is the build vat. How this comes out. It's got set screws in there that actually, so take this out of its plastic packaging. So if you can see the screws inside the machine seat in these wells to center themselves. So that's pretty good. Yeah. Also, when you talk at it, it reverberates back. Fancy. So this film is pretty tightly on there. It's also a little bit dusty, so I'll have to clean that a little bit. It's also, this is nice, it's got a little, so when you're done using this and you want to get the resin out and back into a container, it has a little drain spout to help keep that process neat. That's a nice touch. I like that. Okay, so hopefully orientation of this doesn't matter because I do not remember which way it went in. All right, so that's in and seated. The build plate would go on there. So I can put that on. So nice. Screw that on. So another advantage of these machines over Elegoo Mars I've heard, and some other printers, is that, so number one, the build plate itself is flattened and sort of lapped and then I guess retextured, so it's a flat, good build surface. And also the holder for it is pre-leveled, so you don't have to, you're not supposed to have to fiddle with it. This is refurbished, so that might not be true if the previous owner monkeyed with this, I shouldn't say that, changed the screw settings or did anything in that regard, but it should be okay. There's clearance, some clearance there. Sorry, I'm just looking to see if, so if when this thing goes all the way down and comes back up, if there's enough clearance for it. So I don't know that there is. I'm gonna try this the other way. Looks exactly the same. We'll see. Okay, so that concludes the tour of the inside. There's might have seen it, it's pretty black in there, but there's a window that the UV light shines through in the bottom of the chamber. So then it has an LCD touchscreen, which when they're new, they come, might have one on there, but they come with a protective plastic film on them, which is nice if you dribble resin down the front or whatever, it keeps the LCD screen pristine. So let's turn this, keep turning. There is nothing on this side. There's hinges on the top for the door. Anything on the bottom. One input fan intake, that's the word, and some rubber feet. So that's nice, keeps it pretty secure. And then keep turning it back around. So it looks like these are what they included this hex key for. So since they gave me the key, it means they must intend for me to open it right out of the box, right? So let's do that. It's cracking noise. Let's see if we can let the little green man out. So those. So the screws are pretty, machine screws are pretty tight, but that's all right. Four. See what we can see. Okay, so inside we have. See how I can get this. So on this, out of frame. This is the power converter for the LED lights. The LED array is, so it's I think 50 LED bulbs or something like that, drawing 40 watts. So that's pretty powerful. It's about 15 or 20 watts more than the Elegoo Mars printer. And then there's the control board on the side. The one thing about, sorry, my own curiosity. The one thing about the masked-SLA printers that I don't like compared to filament-based printers is that on filament-based printers, there's a lot of open source software and firmware available, which is cool. You can look at the code if you want to. You can contribute to slicers and software like that. Or if you're curious to find out how it works, you can just open the source code. And if you know how to read code or are familiar with any sort of programming languages, you can sort of figure out or read the comments, which I'm sure that there are in its well-documented code, right? You can figure out how it works. With all of the masked-SLA printers that I know of, the firmware for the control board is closed source. The slicer most often is Chi2box, which I think is part of a Chi2 software. It's closed, it's a black box. It works with these masked-SLA 3D printers, but you don't know what it's actually doing inside. So that's not my favorite thing. But for the price, I'm willing to accept that. There are also some options like Prusa Labs, so Joseph Prusa, who made kind of the first commercially successful RepRap or replicating rapid prototyping 3D printers back in the 2000s. His company, or that company, has a masked-SLA printer and something called the Prusa Slicer for it, which is, I believe, open source. And you can use that to, you can use that to open 3D models and add supports, and then export them as an STL file, and then import them into the Chi2box software just to slice it with the appropriate settings for, and generate G-code with appropriate settings for these SLA machines. Thinking about it, I don't know that the SLA machines actually use G-code. That is probably untrue. Sorry, leave a comment. So, all right, that's the guts of the printer. Should probably just point out this. So it's got a pretty beefy heatsink on the UV LEDs. They draw a fair amount of power, which is also why I have the kilowatt attached. I'm really curious to see how much electricity you got to pour into this thing. It should be significantly less than the FDM printers because we're not melting, so it's not a phase change, so we're not melting filament and then letting it re-solidify. We're using ultraviolet light to cross-link polymer chains in the resin, so the ultraviolet light sort of drives the process, but most of the potential energy is already there. It just triggers the reaction and kicks out heat, so this thing has to have a fair amount of cooling and produces a moderately rigid part. So yeah, relatively less energy. Also, the fact that the SLA or masked-SLA printers can only have a relatively small build volume, which isn't it's kind of an economic constraint because the the LCDs used for the masks are produced for smartphones. I guess that the larger ones use like tablet smartphone screens for the mask. So this kind of the size of screen that you can afford limits your build volume. Anyway, since these have a smaller build volume than the traditional FDM printers, that will also reduce the energy cost of operating one of these. But with the limitation that you can only build parts that are basically that would fit on a smartphone screen and go, I don't know. I don't actually know what the build volume is. I should look that up. I will, and put it down below. But a few inches tall, so pretty small, highly detailed parts because, I mean, the smartphone screens nowadays are pretty high resolution, so you can get very good XY resolution, and this thing has stepper motor inside controlling the z-axis. So the z-axis resolution is, I think, like between 10 and 50 microns, which seems incredibly small compared to, so on an FDM printer, it's a few tenths of a millimeter. This is hundredths of a millimeter. Yeah, hundredths of a millimeter. So it's 10 times better resolution, or maybe a little bit more. So I'm gonna plug it in and see if it is plugged in. I plugged it in a long time ago. I'm gonna turn it on and see if anything happened. Oh, I plugged in the power brick, but I didn't plug the power brick into the machine. Switch it off, plug it in, and then turn it on. Okay, it's got a little Epax logo on there with spots. All right. So the machine starts. I'm going to go get a drink of water, leaf through the manual carefully, and then come back and try printing something. See you soon. Bye. We're not quite, it's not done printing. We're just a couple of layers in. So on layer 4 of 283, but I just wanted to check the kilowatt. So it is it's drawing 67 watts which I assume means that the lamp is on. It's drawing 67 watts whether the lamp is on or not. And then during the cure steps, or when the z-axis is moving, it draws 13 watts, which is quite reasonable. So 67 watts, I mean, it's a pretty beefy incandescent bulb equivalent, but I think a filament-based 3D printer would draw a couple of hundred watts. So this is much more, well, okay. The machine in operation is much more efficient than the filament-based machines, although scaling this up to the size of a filament machine, that would draw quite a bit more power. But also there's a lot of energy gone into purifying and packaging the resin that lets this process go. So there are energy externalities that we're ignoring here, but operating costs for this are pretty low. So I could comfortably let this run for many hours at a time, and it would not influence my electric bill much. I don't know if that's a good thing or a bad thing for the environment, but it's a good thing for my bank account, so it's good. Okay, I'm gonna let this print, go probably do some reading, and I will come back in an hour and we'll see what we see. All right, we're back. The machine gave a loud beep and the fan stopped, which was kind of jolting because I wasn't expecting it. So a dialogue popped up that says printing done, elapsed 1 hour 5 minutes. Doesn't count the seconds, I guess that's okay. And then it says confirm, so I'm going to tap confirm harder. There we go. Okay. So at this point, the next step is to open the build chamber and remove the parts. Before I do that, I'm going to rearrange some things. So specifically, what I'm going to do is so the chamber is now full of vapor from the resin. So when you open it, there's going to be, or when I open it, there's going to be some vapor escaping. So to minimize risk to me and the amount of time it will take to clear the air from the junk that comes out, I'm going to move the stuff off this end of the table and set the air purifier right next to the machine, so it's pulling air through, hopefully away from my face, through the purifier and out, so my apartment stays safer to inhabit. Also going to need a garbage pail, so I'm going to reuse some of the packaging from the printer. Set that about there. This is all subject to revision later. Okay. So now the I'm gonna put this at my feet like a normal person would. I don't have to see the garbage to know that it's to know that it's there. Okay. It's probably blocking some of the light. Okay. Now, I was thinking a little bit more about what I'm actually going to do. I think for the parts that I'm building with this and the size of print you can get, a full dog toothbrush box is probably overkill for the water rinse. So I'm still going to use one for the mean green, but the other one, so this one looks a bit clearer. So to minimize contamination, I'll use this container for the mean green initial rinse, step number 1, and then I'm just going to use a plastic container for the second rinse. And this desk is not big enough for all of us. Okay, so at this point, don't need this. These are garbage. I had a whole hour to clean this space up, and I didn't use any of it. Blew it on YouTube. Oh yeah, so all right. So I spent the hour, so I looked at a couple of the Epax 3D corporate videos on YouTube, and basically there's some basic go, no-go tests, some sanity checks. To be honest, the thing that they recommended doing, or the things that they recommended doing, they did with the bay open, and they told you to check that the light is coming through the screen, which is without any comments about safety or eye protection or not doing things that way. And they were doing it, their model printer in the videos has the orange window on it, so they could have closed it and still seen everything, but they chose not to. So I was rather dismayed by those videos. Information content-wise, they're pretty light, but basically it confirmed that I don't think that I missed any obvious steps. Basically they basically just looked to see that the UV light was on, which I did not do. I thought that when I started printing it would show up, but I couldn't see anything, which means that the screen in the printer is pretty good at masking the ultraviolet light, because I couldn't see any coming out, or it didn't work at all. We're gonna find out. So all right, so I have this set. I'm gonna slide this over so I have a little bit more space. Might increase my risk of inhaling some vapors, but so I will turn this to high speed mode. Okay, so now we're really cooking. I'm going to put on my splash shield, because we're going to be handling some chemicals. I'm going to put on my gloves. The order in which you do this is up to you. It depends on. It's up to you. So I'm going to decant some of the mean green into the large vessel. That is some, oh yeah, high quality pouring action right there. Glad I had my splash shield raised. So for the rinse, the first rinse step, you want to have, so I'm using dilution as part of, so it's kind of important when you're rinsing something, you're trying to dilute the resin that's dripping off the part. So I'm using, putting a lot of fluid into this rinsing container. It's so that there's a lot of liquid to dilute the resin and make sure that there's enough for it to get around. For the water rinse, step 2, I'll put a fair amount in there. So this is distilled water, pure steam. So when you're doing the UV cure, you don't want any like residue from dried droplets to block UV light, and I don't know, I just don't want residues on there, so I'm using the pure steam distilled water, not filtered or spring water, not deionized water, but distilled water. Okay, that's probably too much. It's probably going to splash everywhere, but the carpet will survive, and so will you. Okay, so I have spilled mean green all over my workbench. If we can strain the usage of that term. So now I have a very, very, very clean corner of the workbench. Glad I have a garbage bucket. I'm going to tear off some paper towels in expectation or anticipation of doing something like that again. Okay. These are rattling, which is annoying me. At idle, the machine draws 4 watts, just in case you're curious. All right, dropping my shield. Bad news. So there is nothing on the build plate. So there's the build plate. I'm going to rinse this off. Mean green solution. Let that drain. That's a little bit disappointing. But it means that there's plenty of room for learning and gaining experience. One towel gone. I'm not bothering to rinse this in the water. There might be a residue left on this by the mean green, but I figure if it's dry, it means I've got everything off, and not gonna particularly worry about it. Okay. Now, that's not where that goes. That goes in there. So I'll set this aside. Looking inside the build chamber, I can see an outline of what looks like the part. So it seems that something happened for sure. So I'm going to drop my face shield and try and probe around and see what's in there. If it's stuck to the film, that would be, well, it seems to be. Let's find out. Yeah, so there's definitely some material stuck to the build plate. Happens. To this out, do that. So at this point, I'm going to drain the resin carefully back into the bottle and take a closer look at the film and see if I can gently try to tease the failed print off of the film bed. I'm going to cap this. This air purifier seems to be doing a great job. I can smell my nitrile gloves, but I don't smell any resin, so that's cool. Feels safer already. Okay, at this point it's dripping, but the splash risk is minimal, so I'll let this keep going. Slow, sorry. There's a balance to be struck between preserving resin and wasting time. So I've just reached my tipping point. Okay, so now I'm going to hook this back up. And then rinse this using a mean green solution. Probably should have used a paper towel to lightly try to get some of that junk out there. All of that mean green is now toxic. I mean, it was a little bit bad for your health before, but now it is very much so. Goopy. So now so you can see the failed print stuck to the film in there. It's probably on there pretty good. This is not clean, but it is in a state where I can try to probe it. So I might be changing a film tonight. That'll be exciting. Oh. That's a relief. So the failed resin popped off the film, so I have no points of reference, but I am pleased with the Epax X1 for the material that they chose for the film. It did a nice job of saving me from myself. So this is pretty flexible. Trying to think of something that it would compare to. I can't think of anything off the top of my head, but it is a pretty flexible resin thing. A couple of things I noticed. So when I took the build chamber out, or the reservoir, this thing out of the build chamber, it was warm to the, not hot, but warm to the touch. So there's a fair amount of energy passing through this plate. I'm gonna rinse this some more and then reset, try to figure out what I did wrong, and hopefully come back soon with another attempt to print. Thanks. Okay, new plan. I'm going to put on a new pair of gloves. So I rinsed out the reservoir and with the mean green and with some distilled water, and then dried it out. So it appears to be dry now. There's probably some there might be some liquid trapped in here, but from the first time that I rinsed the mean green, or the reservoir with the mean green, it looks like the resin is denser than the aqueous solution, mean green. So if there's any moisture left, it should float to the top and not interfere with the print. I actually closed. So if you close the window or the door, you can see if this. It does. Interesting. So you can go to the tools and press calibrate. It tells you to ask you to set an exposure time of the test image, which is 200 seconds by default. I'm just going to click next. And it displays this rectangle on the screen. If you look inside, you can see a purple glow, so you can still see it. So I'm going to hit the back arrow because I value my eyesight. So the YouTube video from Epax does that with the chamber door open, which is a terrible idea for your eyeballs. Even with the window closed, there was some purple light escaping. I'm hoping it's not so much UV. Hopefully they chose a good material for this filter window. So the UV light is is coming through the screen works, that means. So the system appears to be okay. There is an option here to set z equals 0. So it tells you to home first, then press that. So what the home button does is it brings this carrier all the way down until this tab engages with a mechanical switch in the bottom of, so pointing with a black glove and a black chamber is not particularly good, but anyway, so it engages, and that is its z equals 0. So then at that point, when you hit z equals 0 after homing, it asks you to confirm that you want to reset z equals 0. I confirmed that, so the machine should be set up, assuming that this is so. They say that the machine comes leveled from the factory, and I'm assuming that during the refurbishing process they double check that. Maybe a faulty assumption, but in the absence of any other knowledge to the contrary, I'm going to hang on to that belief. So now my hypothesis is that the thing I was trying to print is a very lacy part, and I sliced it flat on the bed, assuming that the laciness would be okay. It's possible that it's probable that I don't know what I'm doing with the slicer yet. So I'm going to actually use the USB stick that that was supplied with the machine that has a test part on it. If I can find the thing. Uh-oh. What did I do with it? There it is. It's on the right there on the workbench. Okay. So the chamber is out. I'm going to put my splash guard back on, refill the chamber, put it in the machine, put the build plate back in, and try this again. Toxic waste. So it occurred to me that, so before I was just kind of moving the bubbles around with the spatula. I can take this off. But so what I'm going to try this time is to sweep the bubbles to one side of the build chamber and then use a paper towel to try to absorb some of, basically to burst the bubbles or collect the liquid from them, so that, yeah, so I can actually remove some of this crap. Did that do anything? No. Nope, not really. So then, instead I'm going to try sweeping this up the side. Oh, that'll work better. Sweep it up the side helps you collect some of the bubbles. Yes, now we're making progress. So it's going to make the build chamber a bit messier, so we'll have to make sure we do a good job cleaning this when we're done with this next attempt to print. Should possibly be doing this away from the securing holes somewhere else. Okay. So I'm going to call that good. Again, toxic waste. Buy more paper towels than you think you'll need. I've already gone through a pile of them. So now there are still bubbles in the chamber, but it's a much lower density of bubbles, so I'm not going to worry too much. I'm much more satisfied with this. I think it might actually work. So now I'm going to put this build chamber in. So the chamber actually slides back until it hits a stop in the back, and then the detente holes are lined up with the screws, so that's conveniently designed. Now I'm going to put the build plate back on. It's dry, that's good. Okay, that is tight. Now I can, so before touching the handle on the cover, I can remove my gloves. Again, buy more nitrile gloves than you think you'll need. I've gone through 6 so far. The night is yet young. Okay, so now I'm going to close the bay doors, plug in the provided USB stick. Oh, okay. So that actually sits proud of the machine pretty far, so that won't be a problem to remove. We'll go back, print, and it has so a couple of text files on it. It has a PDF file, but then it has this image of lampshade, it says. So I'm going to assume, I mean, this was sliced by the, or I don't know who it was designed by, but it was at least sliced by the experts. So we're going to press play. So the machine is bringing the build plate down into the bath to the z=0 position. Just waiting to see. So it reached the home position. One major difference I see is that, so this first layer on here is a circle, kind of like a raft that you would use for a filament-based 3D printer. I did not have that on my print. So yeah, learning something by watching what the pros do. So, okay. The downside of this is that their test print, it takes 4 hours. So I'm gonna let this run, and when I wake up in the morning, I'll let you know how it went. And in the meantime, I'll probably work on re-slicing the Mobius strip print that I wanted to print. And yeah, I'll keep you posted. Bye. All right, 3 hours have elapsed. I hope you use them wisely. Let's see what happened. So I took a peek with a flashlight while it was printing, and it looks like it's going to be a good result. Find out. Oh, it's pretty. So it looks like there's some resin trapped that made the resin bubbles is what's going on here. So they're rainbow colored and spanning the, anyway, let's get it out of the build chamber. I'm going to put this down and do some rinsing. Okay, now there are soap bubbles on the print. Risks of splashing are relatively low, non-zero. All right, fine. So, all right, so that's the first rinse. Now I'm going to dry off as much as possible the print and the build plate. Looks like there's a whitish residue on the build plate. That's probably from the mean green that was left on it. after the last or the first failed print. So I guess now I know I've got to rinse this more thoroughly in water after the mean green. So good to know. Okay. So now, all right, that's better. I'm going to cover up my bucket of contaminated stuff and attempt to gently remove this from the build plate. Should have eye protection when things might go popping off without getting goo in my hair. Easy. So basically just took the sharp blade, slid it along the build plate, and it came right off. So it looks like there's an impression in the residue on the build plate, but no damage from the scraper. So everything looks relatively, well, looks as good as when we started, except for I was going to say pristine, but that's not true because it came with some markings and there's some residue on it. But anyway, I think you get what I mean. There's no damage to the build plate. It all looks good. So I'm just wiping this down. I'm trying to tell if that's, so there's some dampness inside, which is not coming off easily. That might be, it might be resin. I don't think it's resin because it didn't dip that far into that. But no. Okay. That about does it for that. By the way, so the air purifier has a PM 2.5 monitor or a display indicating the PM 2.5 value. So that's related to the particle count of particles with a pretty small radius. Need to look at the definition of that. But so right now and when everything was idle, the PM 2.5 count indicated on the machine is about 60 units. During printing, it was at about 100, which I think is from, there is no air circulating within the build chamber when the part is printing. There's only fans, so an input, let's see, probably cooling fans on both the ultraviolet LED in the bottom and the power converter on the side, so the LED power driver. And those are pretty high airflow, they're pretty loud fans, so I suspect it is kicking up dust in my apartment. I don't think that the PM 2.5 measurement is affected by volatile organics or anything like that. I think it was just, getting kicked up. And I made some chicken for dinner after waiting some amount of time for fumes to kind of go down. And there was some smoke, so the PM 2.5 went to a value of about 300 when it was, not uncomfortably smoky, but definitely you can smell the smoke in the air. I should learn how to cook. Anyway, so yeah, right now it's measuring 60, which is a good low value. So I'm just gonna rinse this off again because I can. So now this glove is contaminated. Well, it was already contaminated. Okay. I have used a lot of paper towels today, which was expected that I would use them, but it's still kind of alarming to see how much skinnier the roll is now than when I started, but that's what they're for. Thanks, cheese. Appreciate your sacrifice. Okay, so that is now swirling around nicely. Something about making vortices in buckets of liquid is just so much fun. Anyway, so this is quite bubbly because, it's got soap in it. but it looks good. Okay, let's dry that off. So interesting, there's some, so at the bottom of this container, there are some white, well, they appear white, so they look particulate. It could be a filmy precipitate. So I think that that's the simple green. Yeah, so I guess that's actually quite a lot better. Okay, sorry. So the simple green might have reacted with the resin that was put in there to solidify or precipitate out some portions of it. So I'm squeezing this a little bit, and it gives, it has some give to it, some springiness, but it is a lot more firm than the failed print from before. And so looking at the Epax manual, it has some recommended settings for the ESUN standard clear resin that had a higher curing time for each layer than what I had originally programmed. So they might have used better or more optimal settings when at Epax when they sliced this particular they call it the lampshade model. So that's cool. So I have resliced a couple of files and actually sliced a different file I want to try next using those recommended settings for the ESUN clear standard hard resin, and we'll give that a try. Okay, so that is the simple green rinse. Just rinse it off again because I like wasting paper towels, and these ones still have some absorption in them. Just want to make sure that I've gotten as much of the resin off as I can before using the rinsing it off in the distilled water. So I don't actually have a curing setup yet. That will probably be a brief part of maybe the next video because it's supposed to arrive tomorrow. So this is going to sit overnight someplace, and I want that to be, I don't want it to be leaving any residue or contaminating any surfaces or like this work pad or things like that. So just cleaning it out. So this resin seems to be fairly robust. I'm not treating it with any particular care, and it seems to be fine. It's also quite clear. So on a on a filament-based printer, you see layers everywhere. I mean, it's quite clear that it is built layer by layer, and you can see each build layer. On this piece, I cannot see any layers. So there might be some texture to it that if I look really carefully, but no, it's so the surface is a little bit textured, so it's not like perfectly like crystal clear. Some surface polishing would probably fix or address that. So if I could get polishing wheel in here and on the outside and polish this, it probably would be perfectly crystal clear. So that is pretty cool. I was expecting to see more layers than I am seeing. That is really impressive. And this is with, I believe, a 0.0. I don't actually know what they sliced it with. I think that, so their recommended value is 0.05 millimeter or 50 micron layer height. So if that's what they did, and this is the result, that's impressive. Okay, so that is dried. I'm going to cover this vat of green goo, like the swamp thing might crawl out of. Alright, and then I'm hoping that this is relatively watertight. It's a plastic ball jar, so I'm going to put the part in the distilled water. It sinks, which is, don't know why I wasn't expecting that. I should have, because the liquid sank. Get a nice vortex going. Yeah, tornadoes. could do this all day, but at some point I've got to go to sleep. All right, so that's not where dirty paper towels go. They go in here. Yeah, still gonna treat this as contaminated. So until this has been cured either in sunlight or under an ultraviolet light, there's treated as you would uncured resin. So as if it's deadly poison, as it kind of is. I'm not following best practices here. I'm contaminating the outsides of all of these vessels, and I shouldn't be, so tut tut. So now, if this had been built with supports, now would be the time to use the flush side cutters to trim them. But it wasn't. This was printed with this flat base directly on the base plate and printed straight up from nothing. So it is complete. It just needs to be cured in the sun tomorrow, and then it'll be finished. So I will do that, I suppose, while I'm at work. So again, I guess it needs a couple. So the Epax manual recommends a couple of hours in sunlight or half an hour under an ultraviolet curing lamp. Seems like a lot of time in the sun, and it probably varies based on your location and season. But anyway, I'll leave it in the sunlight tomorrow and see what happens. So I've seen some people, if they have seen or reported yellowing in their prints if they leave it in the sun too long. So I want to avoid that, but we'll see. One of the lessons I learned today was that following the Epax manual's recommendations is not necessarily a bad idea. And this came out pretty well. I'll hold it against a dark background so you can see it. Yeah, that is, I'm impressed by the quality of that print. You can't see, well, there's some interesting parallax effects there. Yeah, that is a nice print. And it doesn't smell bad. Again, I smell my nitrile gloves more than anything else. So that's not a problem. And or the air purifier, which appears enormous next to the 3D printer. So I mean, this thing has a huge activated carbon filter in it. So it is, maybe it's doing an awesome job, no question about that. Just to filtering out everything in the air in my apartment. It's probably also doing quite a nice job sucking the resin vapors away from the printer, and yeah, doing a great job. So I'm pleased with this setup. So the combination of an air purifier, the Epax 3D or X1 model masked-SLA 3D printer, it appears to do a great job. I still need to learn how to slice my own models and learn how to print things so that they will succeed. My novice attempt failed, but I have the printer in my house. I can do this anytime I want to. I have FreeCAD and let's see, so I have a Linux desktop. Nobody cares about this. So I'm using FreeCAD so I can create my own parts, learning how to use that tool. That's reminiscent of SolidWorks, which I used in college back when I was on Windows machines. I also have the Autodesk Mesh Mixer installed through Wine, and that seems to work pretty well. And I also have MeshLab and yeah, some software tools to learn, and in order to get downloaded models to successfully print, and also to start designing some things of my own. I mean, the universe of pre-made parts is vast, but it's still more fun, in my opinion, to have something of your own that you designed and printed. So, all right, that's it for tonight. Thanks for watching. I know this is a long one. I appreciate your patience. Take it easy.